by talking about a word problem. Now, we only have one sort of word problem that we can pose because all we've talked about is this geometry point of view. So far, those are the only kinds of word problems we can pose. So what we're going to do is just pose such a problem. So find the areas of triangles enclosed by the axes and the tangent to y equals 1 over x. Okay? So that's a geometry problem. And let me draw a picture of it. It's practically the same as the picture for example 1, of course. So we'll only consider the first quadrant. Here's our shape. All right? It's the hyperbola. And here's maybe one of our tangent lines, which is coming in like this. And then we're trying to find this area here. All right, so there's our problem. So why does it have to do with calculus? It has to do with calculus because there's a tangent line in it. And so we're going to need to do some calculus to answer this question. But as you'll see, the calculus is the easy part. So let's get started with this problem. First of all, I'm going to label a few things. And one important thing to remember, of course, is that the curve is y equals 1 over x. That's perfectly reasonable to do. And also, we're going to calculate the areas of the triangles. And you could ask yourself, in terms of what? Well, we're going to have to pick a point and give it a name. And since we need a number, we're going to have to do more than geometry. We're going to have to do some of this analysis, just as we've done before. So I'm going to pick a point. And consistent with the labeling we've done before, I'm going to call it x0, y0. So that's almost half the battle. Having notations, x and y for the variables, and x0 and y0 for the specific point. Now, once you see that you have these labelings, I hope it's reasonable to do the following. So first of all, this is the point x0, and over here is the point y0. That's something that we're used to in graphs. And in order to figure out the area of this triangle, it's pretty clear that we should find the base, which is that we should find this location here, and we should find the height, so we need to find that value there. All right, so let's go ahead and do it. So how are we going to do this? Well, so let's just take a look. So what is it that we need to do? I claim that there's only one calculus step, and I'm going to put a star here for this tangent line. I have to understand what the tangent line is. And once I figured out what the tangent line is, the rest of the problem is no longer calculus. It's just that slope that we need. So what's the formula for the tangent line? Put that over here. It's going to be y minus y0 is equal to, and here's the magic number. We already calculated it. It's in the box over there. It's minus 1 over x0 squared, x minus x0. So this is the only bit of calculus in this problem. But now we're not done. We have to finish it. We have to figure out all the rest of these quantities so we can figure out the area. All right. So how do we do that? Well, to find this point, this has a name. We're going to find the so-called x-intercept. That's the first thing we're going to do. So to do that, what we need to do is to find where this horizontal line meets that diagonal line. And the equation for the x-intercept is y equals 0. All right? So we plug in y equals 0, that's this horizontal line, and we find this point. So let's do that into star. So we get 0 minus, oh, one other thing we need to know. We know that y0 is f of x0, and f of x is 1 over x. So this thing is 1 over x0. Right? And that's equal to minus 1 over x0 squared, and here's x, and here's x0. All right? So in order to find this x value, I have to plug in one equation into the other. So this simplifies a bit. Let's see, this is minus x over x0 squared, and this is plus 1 over x0, because the x0 and x0 squared cancel somewhat. And so if I put this on the other side, I get x divided by x0 squared is equal to 2 over x0. And if I then multiply through, so that's what this implies, and if I multiply through by x0 squared, I get x is equal to 2x0. Okay. Okay, so I claim that this point we've just calculated, it's 2x0.